Hello friends, in this video, let us have an introduction to quicksort algorithm. So quicksort is a divide and conquer algorithm. It divides a large array into smaller sub-arrays and then it will recursively sort the sub-arrays. There are three major tasks in quicksort algorithm. First is pivot element selection, then the partition function, and finally applying the above process recursively to all the subarrays. Let us understand it using this example. Let us take an array of 5 elements 10, 25, 3, 50 and 20. We need to sort this array using the quicksort algorithm. So the first step is to pick the pivot element from this array. There are many ways in which we can choose the pivot element. It could be the first element of the array or the last element of the array or the middle element of the array, or we can also pick any element randomly. Here we are going to pick the last element as the pivot element. So our pivot element here is 20. So first task is done. We chose the pivot element, it is 20. The next task is to partition the array. That is, we will rearrange all the array elements in such a way that all values lesser than the pivot should come before the pivot and all values greater than the pivot should come after it. Those elements can be in any order. At the end of the partition function, the pivot element will be placed at its sorted position. Let us apply the partition logic. It is very simple. Let us take two variables, the partition variable p-index and iterating variable I. Initialize both of them to the starting of the array. Here, starting index is 0, so initialize p-index and I to 0. Now check if ARR of I is less than pivot. That is, if 10 is less than 20. And if it is true, we have to swap elements at I and p-index. Both I and p-index points the same element, so 10 will be swapped to its actual place. It will not make any changes in the array. After this swap, we need to increment the value of p-index. So move p-index to next position. Now do the same process with the next element. So increment I. Now compare 25 less than 20. The condition is false, so no need of swap. If there is no swap, we should not increment the value of p-index, so there is no change in p-index. Just continue the same process with the next element. So again increment I. Now compare 3 and pivot element which is 20 and 3 is less than 20, so the condition is true, so swap ARR of I and ARR of p-index. And then increment p-index. And please note that whenever the condition is satisfied, we are performing the swap operation and we are incrementing p-index. If the condition is false, we are just incrementing I. Now do the same process with the next element. So increment I. So now compare 50 and 20 and the condition fails and the array is completed now. Now p-index points to the array index 2. This is nothing but the position of the pivot element 20. So finally, we should swap ARR of ent and ARR of p-index. So swap 25 and 20. Here, the element 20 is at its sorted position now. We can assure that all the elements before p-index is lesser than 20 and elements after p-index is greater than 20, which means the element 20 is sorted now. Now, we need to recursively sort all the elements before p-index and after p-index. So there will be two recursive calls. One is quicksort of ARR, start, p-index minus 1. That is from the starting index to p-index minus 1. That is the elements before p-index. We will not include the p-index here because it is already sorted. And next is quicksort of ARR, p-index plus 1, end. That is from p-index plus 1 to end. That is the elements after p-index. Here, in this array, start is equal to 0, end is equal to 4 and p index is equal to 2. Now, after the partition logic, the first recursive call will be executed. Here, start is equal to 0 and end is equal to p index minus 1. And p index value is equal to 2. So 2 minus 1 equal to 1. So end is equal to 1. And the next recursive call will wait until the task of first recursive call is finished. So sub array from index 0 to 1, that is elements 10 and 3, will be taken. In this sub array, the partition function will be executed first. The same process will be applied here also. Partition index p index and iterating variable I will point the starting index. Here, starting index is 0, so both p index and I will point the index 0. The last element 3 will be taken as the pivot element. Now, compare ARR of I less than pivot element. That is, compare 10 is less than 3 and it is not. So, there will be no swap needed. Hence, p index will point the same index. Now, the array is completed. Finally, we need to swap ARR of p index and ARR of end. So, swap 10 and 3. And since we are doing the process in the original array, it will be reflected in the above array. Now, ARR of p index is sorted. So, ARR of 0, 3 is sorted now. Here, the p index value is equal to 0. So, this function has two recursive calls now like before. That is from the starting index to p index minus 1 and next is from p index plus 1 to end. Like above, the first recursive call will be executed first and the second call will wait until the task of first one is finished. Here, starting index is equal to 0, end equal to p index minus 1, which is 0 minus 1, that is minus 1. But this is an invalid index, 0 to minus 1. So we can't perform the quicksort task here. So when the sub array has invalid index or only one element, we should stop the process. So we should add the condition if start is less than end before doing the process. And this condition will stop the execution when the sub array has an invalid index or only one element. So this recursive call will not be executed here. Now, the first recursive call has finished its task. So now the second recursive call will be executed. Here, start is equal to p index plus 1, which is 0 plus 1 equal to 1, and end is equal to 1. So in this sub array, start and end both are equal to 1. So there is only one element. So we can stop the process now. Here, if start less than end condition will be false since start is equal to end. So it will not be executed. Now, this quicksort function has finished its task. So control will reach the main quicksort function. Here, the first recursive call has finished its task. So now the second recursive call starts its execution. So quicksort of ARR, p index plus 1, end will be executed now. And here, start is equal to p index plus 1 and p index equal to 2. So start equal to 2 plus 1, that is 3, and end is equal to 4. And the last element 25 at index 4 will be taken as the pivot element. Now compare ARR of I less than pivot element. That is, compare 50 is less than 25, but it is not. So there will be no swap needed. Hence, p index will point the same index 3. Now the array is completed. Finally, we need to swap ARR of p index and ARR of end. So swap 50 and 25. Since we are doing the process in the original array, it will be reflected here also. Now, ARR of p index is sorted. So ARR of 3, 25 is sorted now. Here p index value equal to 3. Now, this function has two recursive calls like we had in previous cases. That is, from starting index to p index minus 1 and next is from p index plus 1 to end. Like above, the first recursive call will be executed first and the second call will wait until the task of first one is finished. So here starting index equal to 3, end equal to p index minus 1, that is 3 minus 1, which is 2. So when we check the condition, if start is less than end, it will fail since 3 is not less than 2. So it will stop the execution. So the first recursive call has finished its task. So now the second recursive call will be executed. Here start is equal to p index plus 1, that is 3 plus 1, which is equal to 4, and end is equal to 4. So in this sub-array, start and end is equal to 4. So there is only one element, so if start less than end condition will fail. So this recursive call also will not be executed. Now this quicksort function has also finished its task. So control will reach the main quicksort function. And here it is also completed its execution. And finally, the array is sorted now using the quicksort algorithm. The sorted array elements are 3, 10, 20, 25 and 50. Now let us quickly summarize the quicksort concept. Partition logic will be executed first. After the process, the partition function will return the partition index p index. After that, the whole array will be recursively sorted using the two recursive calls. That is, one recursive call from start index to p index minus 1, that is the elements before p index, and another recursive call from p index plus 1 to end, that is elements after p index. This recursive calls will be stopped when the sub-array has an invalid index or only one element. So this is a process of quicksort. In the next video, we will learn how to implement the partition function from this logic.